The earthquake displaced enormous volumes of water, tens of cubic kilometres, and as that water moved into the shoreline, it created waves up to 24 metres high, which is significantly taller than the building behind me. In the last 20 years, we at HR Wallingford have developed brand new laboratory techniques to help generate scaled versions of these tsunamis in our laboratories. And that has led to a greater understanding of how these waves interact with the coastline and with buildings, and has directly fed into the codes of practice that are now being implemented by engineers. Professor Tiziana Rossetto from UCL came to us and asked whether we could generate scaled tsunamis in our laboratory. The answer after some thought was yes. And that's what started the collaboration with UCL and the development of our tsunami simulator technology.
I started working on tsunamis after returning from the Indian Ocean tsunami and areas affected by this in Sri Lanka and Thailand. Seeing the devastation was a real eye-opener, because I thought that there would have been a lot of research around tsunamis and how they interact with buildings and the coastline, but actually on returning to the UK, I found that that didn't really exist. And so I reached out to HR Wallingford.
So we're here in HR Wallingford's Frood Modelling Hall, and behind me are some of our wave makers that are generating storm wave conditions for this physical model. We can generate big storms with these wave makers, more than 1 in 100-year storms, but they're not appropriate for generating tsunamis, and so we need different technology in order to be able to do that. This is the site in 2009 where we had our first big breakthrough in our tsunami research. And it was in this facility that we created the first laboratory-scale full tsunami time series. So the wave that we generated was a 1 to 50 scale version of the 2004 Indian Ocean tsunami. And in the model, the wave is only about this high. This is the fast flow facility. It's a facility we use every day and has wave and current generation capabilities. Crucially for tsunami work, we can start looking at the influence of arrays of buildings, that 3D effect, and also it's a facility we can put sediment in, so we can have the influence of the wave digging away the sediment, the scour around the buildings. The limitation of the single generator is we're only getting half the story. We're only getting that first wave coming in and running up, and then as far as the experiments are concerned, it stops there. The next big development came in 2023 when we used our own internal research money to develop the dual generator concept, and this allowed us for the first time to capture the incoming tsunami and then control the re-release of that to accurately model the return flow back out to sea.
That was absolutely amazing. I can't believe it. It really is a breakthrough in tsunami simulation. I can't stress that enough. No one has done this before, and I'm just over the moon that we've done it today together with Wallingford.
The next phase of development on particularly the control system of the dual generator is actually moving into a numerical model rather than a physical model to understand how the two generators need to talk to each other.
Create a whole tsunami profile, it will be more realistic to understand what happened to the real tsunami world, because till now there is no such research has been done. I am really excited for that.
What we need now is a new state-of-the-art facility to really push the boundaries further and understand particularly the return flow. Using the numerical modelling, we'll be able to develop the control system and then move back into the laboratory in a new facility once we've got funding, and that will really enable us to move to the next level in terms of our tsunami research. We have the technology, we have an extensive network of potential collaborators already, and there are things that they would like to do that currently we can't do as a community because the facilities don't exist. The one that we are planning and hoping to build here would enable that research to happen.